Hello and thank you for joining me again. Another day, another video. So today I wanted to just give you a brief walkthrough of the Fortinet, or rather the FortiGate SD-WAN feature. I'm going to focus purely on the configuration on the actual FortiGate itself. But let's just start off very quickly with an overview of why you may want to consider a SD-WAN solution from Fortinet. Firstly, the SD-WAN feature is a free or rather non-chargeable feature. It comes as part of the base license of the FortiGate firewall, similar to WAN optimization, server load balancing, explicit proxy. These are all core functions, right? So there's no extra licensing involved in the basic functions of any one of those features. There's one or two optional, 100% optional features associated with SD-WAN, but those are more for metrics. But the actual SD-WAN as a function has no license associated with it. So the other thing with the SD-WAN is that it is completely and 100% decentralized and distributed. All right, we do not have this concept of a single controller that all the devices need to communicate with. All right, so SD-WAN is locally significant to each and every FortiGate. So you could buy a single FortiGate all by itself, and let's say, for example, you've got two different service provider links to the internet. You can use that SD-WAN feature to steer applications over both those links or load balance them. You need absolutely nothing else. You can configure the SD-WAN on box, and it can be 100% standalone. However, obviously, if you're a large organization, global, many hundreds of sites, what you want to be doing is managing it from an orchestration platform. And our orchestration platform is FortiManager, which is represented up here at the top. But again, FortiManager is completely distributed. It's 100% off path. All right, there's no reliance on the SD-WAN feature and the FortiManager. The FortiManager is just there to push configuration, but it also receives telemetry from the remote devices to give you insights into how the SD-WAN is performing, right? So in terms of the SLA conformance, it also manages the complete life cycle of the FortiGates in terms of security, routing, switching, wireless access points, software management, CVE and vulnerability reporting and resolution. So it is a full lifecycle management platform for our core Fortinet products. But as I said, it is completely decentralized, which means that we can lose it completely and your entire SD-WAN system will carry on working. In fact, you can still go to each one of the individual devices and make adds, moves, and changes if you so desire. And then when the FortiManager comes back online, those device level configurations will be automatically synced up with the FortiManager, so you don't have to retrospectively do that. Now, in terms of resilience, so we can have up to 4 hub regions, 4 hubs per site. So in this diagram here, there's 3 hubs. A hub comprises of 2 hub devices, right, for resilience, obviously. I forgot to mention that the FortiManager can also be deployed as resilient, HA clusters, and it can be deployed either as a physical appliance, it can be deployed as a SaaS service, or it can be deployed as a VM either in your data center or in any one of the clouds. Sorry, excuse my phone going off in the background here. Let me just switch everything off on that. So I stop receiving those. So, for example, we can lose an entire hub, all right, and everything will just reroute. Now, let's say, for example, that you had interconnectivity between your data center and the clouds here. Then the SD-WAN traffic trying to reach the data center via the 2 hubs that have gone down would simply be able to use whichever tertiary route you have as a backup here. As I said, maybe you've got IPsec tunnels going directly from the data center to the cloud, or you've got direct connects or any connects or whatever the case may be. There's always a way to reroute around the failure. And as I said, you can have 4 hubs per region. So a region could be the Americas, it could be Europe, Asia, or it could be different regions within America, north, east, south, west, whatever the case may be. How you divvy it up is 100% up to you. We don't have any defined constructs that says you must do this and you must do that. And additionally, sites can communicate with each other directly using ADVPN, so to build shortcuts to circumvent the unnecessary round trips of having to go up to the hub and back down again. So let's look at the SD-WAN on the actual device and the basic things that you need to understand. Now, as I said, we do not have this concept of an SDN controller, software-defined controller that orchestrates everything. All right, so we are not reliant on an overlay, but clearly you can create overlays as well as underlays. Now, these are called zones. A zone purely represents the interfaces contained within that zone. So here I've got my underlay zone, where I've got my two ISP direct links, and here I've got my overlay zone where I've got all my IPsec tunnels. Now, the zone name is irrelevant. I could have called this one Donald Duck and this one Mickey Mouse. It is absolutely irrelevant what you call them, but to me, underlay and overlay made sense. And where this is also used is within security policies, right? Think of it as an object that describes the interfaces within that. So you can see here I've got various policies going from port and internal port to external. And if I hover over that object, you can see those interfaces contained within that object. The SD-WAN determines how traffic is routed into these individual links, all right? It does so intelligently by assigning SLAs, all right, software level agreements, to these devices. So we can monitor jitter, latency, and packet loss on these links, all right, and using those we can then determine how acceptable a link is or isn't, or in contract or out of contract for a given traffic type. So here, for example, I've created a gateway, an SLA pointing to my my outgoing interfaces. All right, I'm pinging 4.2.2.2, and I've chosen the interfaces that I'm going to monitor. Now, these three pseudo probes here, or artificial probes, are just the ones shown within the GUI. All right, we support a multitude of others like TWAMP, TCP Echo, UDP Echo, various HTTP options, and so forth. These are just to keep it simple within the GUI. But as I said, if you go into the CLI or within FortiManager, you will see all the other options. We also support passive, which means we look at the real traffic, the TCP traffic, and we take metrics out of that to determine the three elements here. Or we can use prefer passive. So what prefer passive means is that if there is real user traffic, we'll look into that and gather metrics from that. But let's say everyone at 5 o'clock leaves the office, goes home. There's no longer any user traffic, but you want to make sure that when the next person comes in the following day at 8 a.m. or 9 a.m., wherever you start your working day, that the appropriate link is chosen for that user to immediately start working as efficiently as possible. Then what this device will do is automatically fall back to pseudo probes or artificial probes to determine the liveliness of an individual link. And should that link obviously fail, it'll swing over, and once real-time traffic starts to flow, then what will happen is we will fall back to the actual user traffic. Now here I'm using active, all right, so I'm using the artificial probes. There's my server, and the other thing I want to do, or the next thing rather, once I've chosen my interfaces, and here I can just simply use all interfaces, or I can specify which interfaces I wish to be monitored by this particular probe. Then I set my latency threshold, what defines a link as being appropriate. And you can see here I've got a running commentary on the right hand side here. ISP1 is clearly well within that margin, whereas ISP2 is not. But I could also add in other metrics as well, like jitter and packet loss. The options go from 20 milliseconds up to 3,600,000 milliseconds, right? Then I say, well, how frequently do I wish to do this check? Now here, this will depend on how aggressive you want to be. Here again, the check interval, I'm just going to go wild here, and it's going to tell me what the minimum value is here. So is between 20 milliseconds and again, I think, let me just double check here. Just put a wild number and then it'll come. There you go. So it's the same, all right, between the two. All right, so there's my check intervals. Here I'm going 2000, so that's every 2 seconds. And then if I lose 2 probes, so 4 seconds, then declare the link down. If I have 2 actives, so also in another 4 seconds, bring that link up again. And if I'm using static routes, then update the static routes. Now, in this particular case, for my, or certainly for my other links, I'm using BGP and or OSPF. Now, you want to be careful of how aggressive you make this, because clearly if you are pinging something like this, which is out on the internet, that particular service may get a bit upset with you if you are running a denial of service attack against them by making this too aggressive. And as you can see here, I can have as many of these SLAs as I want, depending on what sort of services you wish to monitor. We then create our SD-WAN rules, and this is where we start bringing things together. So if I look here for my Skype, for example, the source, I don't actually have to put that source. If it's any, then if I just left that like that, it's just going to assume any or all, right? So that, there's all your destinations. You can create your source IP address, or if you've got dynamic objects, like here I've got dynamic objects coming from my EMS server, all right, depending on whether devices are compliant or not with their security posture, then these objects will be automatically populated with the relevant IP addresses. But that's irrelevant. Whatever your source IP address is, you put it there. Now my destination, obviously if my destination is an IPv4, I'll put that here, or I can use the Internet Services Database. Now the Internet Services Database is simply a database of IP addresses associated with a particular service. Now I don't have to use this. I could just use the application, because remember that the FortiGate is a next generation firewall, so it's fully application aware. But this is just a belts and braces. Now the reason I don't want to purely rely on this Internet Services Database is, imagine you've got, like here, 416,000 IP addresses. How can you possibly know as a customer that one or maybe more of these IP addresses haven't been compromised or subject to a DNS spoofing attack or something like that, right? If we marry that up with application control, we can make sure that that traffic coming back down that link is 100% Microsoft Teams and is not something nefarious which you would rather not have coming into your network. Once I've established those two, I then choose what's my outgoing interface strategy. Now here I can go manual. I can say I don't care about the SLA. If ISP1 is up, use ISP1. If ISP1 is down, use ISP2. And as I mentioned earlier, it will simply parse these interfaces from top down. If I wanted ISP2 to be first, I'd simply put that first and ISP1 second. My other option is best quality, and this is where I add in my SLA checks, because this is obviously going to correlate that against the actual data for that, or rather health check of that interface. The other is lowest cost SLA, and here is where I can use any one of those, all right? But I can also load balance across those, and I can also start marking or remarking packets. So let's say, for example, you are sending traffic maybe to an MPLS network, and that MPLS provider has given you a gold, silver, bronze SLA on their MPLS network, and those marry up with certain DSCP or TOS markings, so we can put those here so that this particular traffic is placed into the correct queue. What I can also do if I use best quality is I can create a customized profile. So I can use a percentage of all of these to calculate the best possible path. All right. But in my case, I'm just keeping it simple and I'm simply using latency there. And you do that for every single one of your applications. And you can see here that the device has told me which are the relevant interfaces that it has chosen based on the criteria. Now, we're not just bound to jitter, latency, and packet loss. I can also use downstream and upstream bandwidth. Now, where I can get that from is one of two places. So if I come along to my interfaces here, and let's just look at this. You can see we've got a feature here called speed test. Now, this is one of those licensable features that I mentioned earlier. It is not mandatory. You can choose to have it. Where it is really useful, though, is if you've got links of that vary, their speed or their throughput varies over time, maybe LTE, okay, because LTE being a radio link is subject to shadowing, reflection, and the various physical things that affect a radio link, and you may want to constantly check the speed of those links for conformance to various type of traffic. You can use that here. Or we can artificially steer. Now here I've artificially made this DC1 look like it's got a much higher upstream and a very low downstream, and I flipped this on its head for DC2 VPN. Now note that this is not in any way, shape or form affecting the real throughput of this link, right? It's purely an artificial traffic engineering method. And I can take that, and as I said, I can use it within these rules to determine upstream, downstream. Now, why may I want to do that? Well, I know that ISP2 has a much worse latency than ISP1. So does that mean I mustn't use ISP2 at all? Well, that doesn't make any sense because I'm paying for ISP2. So by doing this, I can send traffic that's not latency sensitive, like Office 365 and Gmail, up that link, and I can retain ISP1 for my latency sensitive traffic, like ISP1 here, right? So Skype or Teams is obviously voice, it's latency sensitive. Now, the other option I forgot to mention is that, or I don't remember if I mentioned though, is that we also got the option to load balance links. So if you've got equal links and they're both performing the same, we can load balance across those links as well. Now, from a traffic perspective, I've already mentioned applications and the ISDB, so we can also do TOS marking. So here I've got one policy for expedited forwarding, another one for a short forwarding 32. I can do destination IP addresses, all right? So you're not bound to any specific subset of capabilities. You can use them all concurrently in the SD-WAN rules. So really, at the end of the day, that is as simple as the SD-WAN gets. It's very feature rich. It's very simple to deploy, all right? And we've got some metrics that we can have a look at here. So here's my IPsec tunnels. All right, so this tunnel is running as an aggregate. So an aggregate is like a port channel for IPsec. So I've got two links within there, and they are load balancing across each other. Now I can take this aggregate, although it's two links, I can have it appear to be a single interface within my SD-WAN, as I have done here. You see there, core aggregate. Now I could add another interface to this, all right, if there was something else going to that same destination, but there isn't, and I could put that as a tertiary. Now core aggregate has obviously got two links going via two diverse paths, but if both of those went down, I could have a tertiary path as a backup if I so desired, all right. Now, the next thing we can do, and this is where that dynamic speed check comes in, is in terms of traffic shaping. So if I do have links with varying speeds and performance profiles like LTE, then what I may want to do is ensure that no matter how the bandwidth of that link or the quality of that link varies, certain types of traffic always get an appropriate quality of service over that given link. And the only way to really do that on a varying link is to use a percentage profile. So it says, well, at 1 second that link is 10 megabits per second. The next minute it may go down to 5 megabits per second, but it doesn't matter. Skype, for example, will always get, I don't know, 5 or 10% of that bandwidth, irrespective of what it is, right? So we can apply shaping policies and shaping rules on an application basis. So you can see here, just like with the SD-WAN, because again, the FortiGate is a next generation firewall, I am using my application awareness in here, and I'm assigning that to the traffic engineering rules, all right, to make this as accurate as possible. Now in this particular box, because I don't have varying links, I have simply created static dual leaky bucket quas profiles here. So there's nothing mathematical and mathematically pure about how I've done these. They're just purely for a demo perspective, all right? So they may not make any sense because they're not designed to. Right? As I said, they're just for a demo perspective. But in a real world, I would look at my traffic type and I would divvy these up so that the cumulative total of all of them added up to 100% of whatever that link bandwidth is. Now, why do I say it's dual leaky bucket? Is because we've got a guaranteed bandwidth. That's what this particular application will get, no matter how saturated the link is. But if there is headroom, we allow it to burst. Obviously, if there's no headroom, it'll get clamped back to the guaranteed or to a percentage of what's left over. All right. Here I've got my low priority, and anything that doesn't conform gets thrown in here, and you can see that out of contract traffic here is being discarded heavily. I'm not running any of the other traffic at the moment, which is why you don't see any matches there. But here is where I can create my percentage profiles, and I can create multiple classes. I can give a class a name, and I can give it a percentage here, say 20% of the bandwidth, and my maximum bandwidth 30% or whatever the case may be, and then I can give it thresholds here, okay? And then that will come along here, and then I'll do the next thing, which could be Gmail or Office 365 or whatever the application may be. Now the other thing you can do is you can create custom applications. So if I come along here, I've got my application signatures here. There's many of them. But if, for example, there's some application that you've written as an in-house application and you want it to be steered by SD-WAN, you can simply come along here and create a custom application signature, and the information in terms of how to write that signature is available on Fortinet.com. So that was just a very quick overview in terms of how the system works. All right, so here's the traffic shaping dashboard. So in the interest of brevity, so I don't want to have these videos go on too long, hopefully that was clear. Hopefully you can see some value. Now, I did not include the FortiManager specifically for that purpose of brevity. All right, my intention, I will do another video later on showing how you orchestrate and manage the entire life cycle of SD-WAN across multiple sites using the FortiManager. So for now, I thank you very much and I bid you farewell.